How's it going, everyone? Julian Gonzalez here. Today we're gonna talk about is this thing called generators in the JavaScript language as a way to explore and first understand how do we get here and why we need to look at generators. Why do we even have generator in our language? So we can discover is what is the problems that generators is trying to solve, and that's exactly what we're going to do in today's video. So this is a model from Resyncing the Synchronicity in JavaScript, which is a course taught by Kyle Simpson, as a way to now understand conceptually and practically how can we going to handle as a JavaScript developers our concurrency in our asynchronous programming, which is something that we as a JavaScript developers, we need to take. This is a calls to arms because the next level of competency as a JavaScript developers is to be strategic and tactical when it comes to provide your solutions to business. So at the end of the day, what they want is that you are capable to now translate is technical details into business implementations. Let's get into this. I actually also put here this functional light JavaScript course because at the end of the day, a lot of this concept that in asynchronous programming, especially the promise, is using is functional programming, right? And now Kyle Simpson as well have a course that taught about that. We're not going to dive deep into that. We're just going to describe that how these particular concepts are needed as a way to understand now how can we deal with the concurrency using promise, and also what is some of these particular concepts that we are going to use in our daily lives. So for example, purity, which is giving a function. Remember, because this is all about functional programming, the thing here is that it's all about functions. And in JavaScript, functions are first-class citizens. So that's a great thing. So the idea here is to now understand and apply these particular concepts, something that you're gonna do that in today's video as well. But understand the concept of purity, which is you have a function that takes one argument. Anytime you receive the same input, it's gonna get you the same output. You have also arguments adapters, and arguments is the values that we pass to parameters, and the parameter is the definition of the inputs. All right, and how can we now is transform is the shape of this function. And any time when we talk about shapes in functions, we mean is the parameters, right? The inputs. So in terms of inputs, so functional programmers and functional programmers are very obsessed with that, with this shape of the functions. So we have adapter functions as a way to say, hey, if we're going to receive multiple arguments, let's going to call this as an n-entity. But if we're going to receive two, binary, or one, unity. And most of the time, the most useful functions, especially if you're going to work with this, are the most usability is with this is with the unity functions, right? Or binary functions. So we also look at the half, which is the high order function, which is a way of how you can now pass as a argument to this function. Is a set of functions to run based on that specific instructions to produce or to run something that is specific, or you want to these particular functions now generate is a specific set of instructions, right? So the TLDR of this is HOF is just function that receive a function as an input and as an output. And when we talk about that is set of instructions. You might wonder, why do we want to receive a set of instructions? Because somehow we want it to now is or run a specific computation with this set of instruction, or to generate a new specific set of instructions for someone else. That's very interesting because this higher order function is summarize the idea that we can now is derive computations. That's very interesting. And we also have the point free, which is now the relationship between is the shape of the function's arguments, all right? Something that we use a lot. Transaction, which is now the way of how you can now mathematically shape the argument of a function, okay? So to make their shapes compatible, again, this goes beyond the scope of this course. And then we have monads, which is the main use case of monads. When I talk about is in terms of usability from the JavaScript perspective. And again, this is not a topic that we're going to dive deep in today's video. It's just as a way to describe this, because when we jump into generators, that's what we're going to do. We need to understand these things. And monads is, from the usable perspective, is this particularly functional data structure that allow us is to keep track state change. Why is this? Because after all, monads is a way of how it will generate is now a new monad, a new data structure with the transformations applied to that. So, all right. So we also describe here things like map lazy and lazy array. What actually does it mean by that? And this is now what we want is to evaluate, or we want to apply some transformation to a data structure, all right? That instead of being now fixed, is actually time dependent. In other words, this is a time data structure. That's quite interesting. For example, observables. This is when things get in here. And why now a lot of applications, a lot of business actually are eager to develop here, because at the end of the day, this is something crucial to understand now how they can provide is business values to companies or to users. And you may wonder why, because now, for example, if you are now an application or a business app that actually wants to now transmit data over the cable. So let's say you are in the telecommunication and that you want to now transmit this data in the most performant way possible. You can do that, all right? Yeah, you can do that. You can do that by actually using this particular representation, this data structure that allows to do. So useful, for example, when working with streams of data, video, audio, file sharing, right? So generators, here we are. So generator is a new exotic function introducing EXX, right? So EXX actually was launched in 17 June 2015. We're almost 10 years. Oh my God, this is a decade. This is a decade for us to actually understand what is this. So we're going to look at the mechanism first, how that works at first, and I really love to this. And at first, when you look at it, doesn't doesn't look like you have anything. It doesn't look like you have seen anything before with asynchronous programming. It's going to be strange and out of place, but this is the fundamental part of the whole picture. So if promises are about to solve the inversion control issue and callback hell, generators are about to solve the non-local, non-sequential reasonability problem. If you have followed me along with all of this concept before, so this inversion of control, it means that by the time that we have to pass a callback, if you're using timers, right? If you're using the callback approach, by the time we have to pass a callback to someone, or in this case, by the time we pass this set of instructions to a timer, we put then in control of our code to decide when this will run and and when this piece of code will run. So we don't have control over that code and all of that thing. And that's when this trust issue begins, because that's great, that's good. So we don't know when this code will run, and also not only so we know when this code will run, but can we make sure that this code doesn't run too many times, a few times, not too early, not too late, don't swap errors, don't lose the data context, and so on and so forth, right? So now we have promised that act as a placeholder. Is the idea around that we need a placeholder to eliminate time as a concerning factors around a value, or a wrapper around a value. So this placeholder, this promise object, you can think of this like a listener, as an event listener of this data, that once they arrive, you can subscribe to this particular event. So it means that this particular data structure, this object, is going to be responsible to actually provide you the data when it's needed, and guarantee you that it will have at a time. It will not trigger. It won't trigger too many times, too few times, too late, too early, and also it is immutable once you get that, right? So what you can do is just subscribe to that under the .then property as it is. So you pass a callback to the .then, so as a way to get that value and then act upon that. And with the .then is also now enable us is to this flow control as well as data flow, right? It means that we can now change multiple promise or multiple, for example, Ajax requests, future data that we're gonna get at some point. So we can now compose this data. So this is quite interesting. And this is something relevant, especially if you're working for backing applications, when there is a lot of things going on, a lot of moving, a lot of data, a lot of service that you need to consume and wait for the response, so you can then compose that data and so on and so forth. So for example, if you have an e-commerce that you want is to, by the time the user click on the checkout, you want to send a request to the payment card, whatever it might be, payment card service, okay? Let's say Stripe by default, and then you get that, and then you get that data. So once that transaction is being done, then you now want is to store that in your database, okay? And also, send, after you do that, so now send so fire a request to your analytics servers, so you can keep track of that operation, right? So the point of this is that you have to now talk to several of these services along the way. So now this help us to cover this particularly common and complex operations that callbacks fell short when we need to actually deal with this, right? So promise actually comes here and say, hey, this is what I can offer. And also there are some abstractions for that, for example, like .all settle, or .any, and .raise to help us to cover the most common use case when dealing with this concurrency. So hey, fulfill all the promise, fulfill when all are fulfilled in the case of .all, and reject if any is rejected. In the case of all settle, is like fulfill all settled promise, okay, or resolve all settled promise, whether it is resolve and a response, resolve or reject. Provide me this now as a collection of that. And the other is raise. Hey, which one of them actually was resolved first, and then give me that. So all of this abstraction is just to describe that. And how now when people ask you, is like, hey, how this promise generator or how this promise works behind the scenes? Well, it's because it relies in the things called the micro task, in the event loop notion, to actually now adding all of these micro tasks or this promise callbacks here. And by the time that they get the data, it's going to now pass. So the event loop is going to evaluate now the micro task first until exhaustions, and then the callback here. So this is now a interesting a careful thing. This is when you need to be careful, especially when you are now working with this promise like, because the more you add to this sequence or to this micro task, you can have an infinite loop in there in the micro task, so it will never reach to the callback queue. So just a way to consider that, especially if you want to work with service worker and that kind of thing. But in any case, here we are, generators, right? So generators, if promise, okay, so if promise is all about solving the inversion control and callback hell, generator is all about solving, or it's all about generators are about to solve the non-local, non-sequential reasoning, especially when you have now with promise, right? Because you can define some code here, or by the time you now pass a callback to this .then function, or this by the time you subscribe to the .then, okay, or the .catch, all of these functions can live for modularity in other files, right? So you have to do all of these non-local jumps, and this is when things started to get not readable for the developer's perspective, especially because as things comes here. So for example, you want to handle these things that comes in first, and then once that is done, you want to handle these two things, and by the time, if these things fail, so you want to actually catch things, and if these things pass, you want to handle this particular scenario. So by the time you handle all of this, it becomes now problematic, and we are actually not wired to actually handle with all of this. So our mind is much more, so works when we plan things, we do it in a sequential blocking way, right? So this is now the value proposition of generators, right? Hey, I'm about to solve the non-local, non-sequential reasonability problem, and let's get into this, right? So they're going to provide a powerful pattern for that. So we need to understand the plumbing and how that works. I really love about that word. I really love about plumbing. Yeah, my friend. I really love plumbing as a word. In Spanish, this is plomería. I really love the plomería that we need to pass through. Yep. Absolutely. All right. Okay. Absolutely. So, to understand that plumbing or the mechanism, all right. So remember that at the end, so all functions have this fancy name term run to completion. Let me see if we can find actually this one. Function in MDN, right? And then you got now generators in MDN. Let me see if they describe something related to run to completion. Yep. Okay, for functions. Generally speaking, a function is a subprogram that can be called by code external or internal in the case of recursion to the function. Like the program itself, a function is composed of a sequence of a statement called the function body. Values can be passed to function as parameters, and the function will return a value. In JavaScript, there are first-class citizens, that's right, and then return from function and assign to values and property. They can also have property and methods just like other objects, because after all, they are special kind of objects. And by default, it is a function execution doesn't end. Okay, by default, if a function execution doesn't end in a return statement, or if the return keyword doesn't express at all, the return value is undefined. So the return statements allow you to return an arbitrary code from the function. One function can only return one value, but you can simulate the effect of returning multiple values by returning an object on an array or destructuring there as a result. But all functions, after all, return something. Those that you don't explicitly indicate what it's going to return, it's going to return undefined. Okay. So passing arguments here, so parameters and arguments have a slightly different meaning, but in the end, okay, parameters and arguments, that's right. Arguments are passed by value and never passed by reference. More precisely, object arguments are passed by sharing, which is the reference called by sharing. So this is now a reference that you pass here. This technique was first noted by Barbara Liskov. All hail to you, girl. It is used by many modern languages such as Python. The shared values being called objects, Java objects, Ruby object, JavaScript objects, scheme, data structures such as vectors, and AppleScript. OCal and ML, reference, records, array objects, and other compound data. Maple, Airtables, and TCL. Jesus. So, all hail, shout out to Barbara Liskov. Holy hell, is she alive? 85. Holy moly. Liskov has led many significant projects, including the Venus operation system, a small cost, low time sharing system. The design of implementation of the CLU argues that the Fairchild language to support implementation of distributed programs and to demonstrate the technique of promise pipeline. And a Thor, an object-oriented database system. With Geneti Win, she developed a particular definition of subtyping, commonly known as the Lissab substitution principle, which is part of the object-oriented programming. It's like, hey, base class, child class should replace its base class or parent class. She led the programmer's methodology group of MIT. with a current research focus in Byzantine fault tolerance and distributed computing. Holy, okay. All right, okay, all right, Barbara. All right, Barbara. Good. So yeah. Okay. So call by sharing or passing by reference, which means if the object property are mutated, the change will impact outside of the function. So this keyword refers to the object that function is accessed on. It does not refer to the currently executing function. So you must refer to the function value by name, even with the function body. Defining functions. Broadly speaking, JavaScript has 4 kinds of functions. Regular functions. Okay. So broadly speaking, JavaScript has 4 kinds of functions. So far we have a look at the regular function. Okay, they can return anything. Always run to completion after invocation. Okay. Generator functions return a generator object that can be paused and resumed with the GIL operator. We also have now async functions. This is an async function. Returns a promise and can be paused and resumed with the await operator. And then you have async generator functions. Returns an async generator objects. Both the await and GIL operators can be used. Okay. So we have now 4 kind of functions. Regular functions that can return anything and always run to completion after invocation. Hey, this is the set of instructions that I want you to do. Generator functions that returns a generator object, where now a generator is this is an object that is returned by a generator function, and it conforms to both iterable and iterator protocol, right? It means that you can now the iterable protocol, it means that it will follow, okay, this JavaScript object allows you to define and customize the iteration behavior. Okay, hey, what is the iterable protocol? Hey, what is the iterable behavior that this particular object will have? In this case, the generator. And what is the iterator protocol? Which means that what will be now the way of how this going to produce a sequence of values. But this is important to understand these 2 terminology. And again, iterables is something that is not from JavaScript. It is also come from Python, similar for generators. Okay, but iterable protocol and iterator protocol is all about that. Okay, so it conforms, this generator object is conform, it returns you an iterator, which follow is the iterable protocol. Hey, this will be the algorithm or the set of instructions. This will be the iteration behavior. Okay, so just what values are looped over in a for of construct, right? Exactly. So what are the values? You got it. So the generator object is returned by a generator function, and it conforms to both the iterable protocol and the iterator protocol. So the iterable protocol is like, hey, let me customize now is the iteration behavior, right? And the iterator protocol says like, what will be the sequence of data? What will be the protocol or the standard way of produce a sequence of values? And in this case, it returned now, or it exposed you now a particular object that called is the next as a function, and some other optional value like dong and value. So this slowly, but again, 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 because the end goal of generators is to solve this. It's all about, generators are about to solve the non-local, non-sequential reasoning problem, right? So okay, all right. So this is now the generator, which is a special type of functions that allow you to pause or resume with the yield operator. So like regular functions, we can now is that they run to completion, which is a fancy name to evaluate all of this statement until the return keyword, or until that is done. Okay, generator functions have now the ability to pause and resume with a yield keyword, with a yield operators. So async function here, okay, is another one. Async functions here is another type of functions. Async functions declare, create a binding for a new async functions to a given name. The await keyword is permitted with the await keyword is permitted within the function body, enabling asynchronous promise-based behavior to be written in a cleaner style and avoiding the need to explicitly configure exactly, and avoiding the need to explicitly configure promise change. That even though this promise change is great for this flow control, but it's not for readability or for this problem of non-reasoning, non-local as it is. So you can also define async function using the async function expression as it is. Yeah. So this is a function, but an async function declaration creates an async function object. Each time when an async function is called, is returned a new promise, which will be resolved. Each time when an async function is called, it returns a new promise. Okay, which will be resolved with the value returned by the async function, or reject with an exception on call within the async function. Async function can contain 0 or more await expressions. Await expressions make a promise returning functions behave as thought they are synchronous by suspending execution until returning promise is fulfilled or rejected. But this is the way of how now you can actually mimic this behavior. It's like, hey, behind the scene, this async function is my using its generator. The purpose of async and await is to simplify the syntax necessary to consume promise base. The behavior async and await is similar to combining generators and promise, because it's like you calling to this promise inside of this generator, okay, and by the time you get that, you're gonna call the next. So by the time you call it, you're gonna get that. Let's get into this, right? So this is okay. So we also have another type of function, which is async function. All right, returns a promise and can pause and resume with the await keyword. Here with the generator functions, we can pause and resume the yield keyword for synchronous operations. But when we want is to now pause the execution or wait for some computation to be done after X amount of time, we can do this. Async generator functions return an async generator objects. Both await and yield operators can be used. Interesting. All of this is because we're handling is a concurrency problem. The async generator object is returned by async generator function, and it conforms to both the async iterable protocol and the async iterator, async iterable and iterator protocol. You have the async iterator and async iterable protocol. And there is another part of protocol used for async iteration, named async iterator and async iterable protocol. They have very similar interface compared to the iterable and iterator protocol, except that each return value from the calls to the operator, to call to the iterator method, it is wrapped in a promise. Iteration between the language and iteration protocols. All right, okay. But we know that there are 4 types of functions, right? And each one of those functions has its particular anatomy, their behaviors. Good. So construction, declaration, expression. The function is anonymous but assigned to a variable. The function has its own name, arrow function, and methods. So this is just the way of how you can declare our function, right? You have now 1, 2, 3, 4, 5, 6 way of defining functions. Whether it's a constructor, or a declaration, or in an expression with the function keyword, with a name function, or the arrow function, or inside of a method. See. All right. So all syntax do approximately the same thing, but there are some subtle behaviors difference. The function constructor create a full-fledged function object which can be construed with the new keyword, which is exactly what is due here, right? And that's when the object programming kicks in. However, arrow functions and method cannot be constructed. Async functions, generator function, and async generator functions are not constructible regardless of their syntax. So so they not construct objects behind the scenes, so they are not constructible. The function declaration create functions that are hoisted. Other syntax do not hoist the functions, and the function's value is only visible after the definition. The arrow function and function constructor always create anonymous function, which means they can easily call themselves recursively. One way to call an arrow function recursively is by assigning it to a variable. The arrow function syntax does not have the argument of this exactly. The function do not have access to argument or this, and the function constructor cannot access to any local variables. It has only access to the global scope. When you use the function like this instead of function declaration, and the function constructor can cause runtime compilations, and it is often slower than other syntax. This is the constructor for this. But again, the point of this is to recap about this function, the type of the function, and how you can declare that, right? Why this is important? Because this is the core, one of the core of the language itself. One of the core of the example of the language itself. So, all right. Let's keep moving. So we have so all functions, all right, all regular functions, all regular functions have this fancy term of run to completion, because it can return anything, right? A primitive or an object. So what it means is that anytime a function is called, it will execute until the end of that function, as we mentioned before. So that doesn't mean that stopping us from calling more function. And one of the great things of this function is that functions, and this is a very fundamental property of the function, is that this run to completion. It means that no matter what, no matter what, if there are any other instructions to run, I'm just going to run all of this code until completion. So it means that doesn't mean that stopping us from calling more function, right? So it doesn't stop us to calling from more function, but this function execution must be run to completion. It is that no one can preemptively interrupt the function to run something else. So let's say you are now making is a strawberry pancake, right? You have now the batter. You're gonna put all of the, so you already add the eggs, the flour, the salt. Now you cut the strawberry in different slices. You put in there, which is a great. You twist that, and now you put it on the stove. Okay, a fry pan, okay, or a pan. You put that on a pan, right? So you put now this batter on the fry pan, right? And all right. So as you do this, all right, this run to completion feature is like if something happens in between. Let's say while you are pouring the batter into the fry pan, and then your mom call, you're going to run to completion this, and then if your mom's end calling, or for some reason hang out, well, you later on gonna call her, but you first need to understand. You need to finish this. This is something. This is a very fundamental feature of concurrency, because no one can preemptively run something, which is something that they mentioned here. No one can preemptively run or interrupt you until. So no one can suddenly interrupt you to do that until completion. So another good example, or a very more practical example, is that when you go out, when you hit the gym, and then you are now doing squats, all right? Let's say that you're doing squats or bench press. Okay, if you're doing bench press, if you're doing chest press, and if you're carrying, for example, in the case of women, 70 kilograms, or in the case of men, 100, all right? As you do that, all right, no one can preemptively interrupt you to do something else, right? So no laugh, no joke, none of that S, right? It's like you are doing that because if you don't focus yourself, you're gonna die. You know, your function executed. So that's a good example of how now this concurrency in real life actually work as it is. And this is something important because now when you can able to, well, if you're able to describe this, you'll now be able to apply that to your programs and understand now how, for example, and that despite that it can be pretty academic, this run to completions, it is very important to understand these concepts, because when you're dealing with multiple programmings at the same time, this is when you now have to make sure that, hey, that the memory that the sharing is not corrupted, that you have some technique to actually verify which function go first and then the other. Something known as the semaphores. So it can be very problematic here, and this is some concept from multi-threading programming, right? Where they need this kind of, when they don't have this kind of concept of run to completion. So generators are not run to completion, and they're no way to bring chaos to the programming. In fact, they're just to introduce a particular behavior. So when you see a particular features that is added to a language, to a program, some of the time they want to add is a behavior, a recurring behavior that happens in there. So in the here with generators, so they are not run to completion. They are not to bring chaos here. It's just a way to introduce you to this behavior that previously we don't have to. And if we want to actually try to simulate this behavior, it requires a lot of work to simulate that. So now it's a syntactic sugar for the behavior that we need to simulate that, right? And generators come from Python. So the JavaScript generators is a syntactic form of describing a state machine. Okay, all right. So first we talk about is this function concept. Okay, so first we describe is this function run to completion, which is one of the features that this all regular function has. In JavaScript you can have several type or kind of functions. Okay, regular function is one of them. You also have is generators, async functions, and async generators. For the case of our example, we want to only describe is these regular functions, and they have now this feature called run to completion. Because if you can imagine, if you hit the gym, you do it, you're gonna do chest press, okay, with 100 kilograms. You definitely want to focus on that. You want to really run to completion there. If something goes wrong along the way, you might die. You know, and this is somewhat similar here to the function, because no one can preemptively interrupt you to run some arbitrary code, to run something here, right? To run something else. And this is now is very important, because this multi-threading programming that where they don't have this concept of run to completion, where the idea here is that they can now preemptively have all of these interruptions of the code to run something. And that's what they need to check is that, hey, why do we have in memory? So we don't actually corrupt our memory. And this we have now share. Okay, that's when you have now things like shared resource lock-ins and semaphores and all that kind of wildness that multi-threading actually has. But luckily for us, this regular function have that. But generators Does not. And this is not to bring chaos to this. This is in fact just to bring a behavior that when we need to simulate that in JavaScript, it requires a lot of work. Makes a lot of sense. Makes a lot of sense. So this behavior that give us the ability now of to pause and resume is something that comes from Python, and this is a syntactic form. This is interesting. Generator is a syntactic form of describing a state machine. When you talk about syntactic form, provide me some couple examples about what syntactic form means. Let me ask here, Perplexity, what syntactic form means? Provide 5 examples. This concept is crucial in linguistics, and as it helps convey meaning and ensures that sentences are grammatically correct. Syntactic forms can vary based on the type of sentence being constructed, such as declarative, interrogative, imperative, or exclamatory. Example of syntactic form. But syntactic form refers to a specific arrangement of words and phrase in a sentence that determine its grammatical structure. The conceptual is crucial in linguistics, as it helps convey meaning and ensure the sentences are grammatically correct. So, okay, this particularly arrange of words, okay, and in this case, these particular ways of arrange token as generators, okay, is a syntactic form to describe is a state machine. So a good example of this syntactic form, okay, that wants to convey to a meaning, okay, is, for example, is like what is this collection? What is this arrangement of word actually convey? What is the meaning of this? The dog barks. Hey, yeah. Okay. I'm hungry. I would like to get paid more for my job. It's a meaning. It conveys a meaning, right? Okay. Interesting. Very, very, very interesting. Very, 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 very interesting. Okay, Jesus. Jesus. All right. God damn it. Syntactic structures. When he mentioned, oh my God, this is huge. When he mentioned syntactic form, is how this in syntactic in the syntax, okay, syntax. What is syntax? Okay, it's a fundamental aspect of linguistics that focuses on the arrangement of words. Okay, word order, sentence structures, grammatical relationship, phrase and clause, and so syntax is the fundamental aspect of linguistics that focus on the arrangement of word, phrase, and clause to form grammatically correct sentence. Grammatically. So what is grammar? Oh, here we go. It's a comprehensive system of rules that govern the structure of a language. Okay, a set of rules. Okay, a set of rules that govern, according to this, a set of rules that govern the structure of a language, including how word, phrase, and sentence are formed and organized. It encompasses various elements such as syntax, the arrangement of word, morphology, the arrangement of word, morphology, the structure of the word, phonology, the sound system, like right now, and semantics. But this grammar, which is a set of rules that govern the structured language, that is made of the arrangement of word, the syntax, the morphology, which is the structure of the word, the sound system, phonology, and the meaning of this. Jesus French toast guy, bro. Oh my God, people that actually build language, they're another level, bro. Jesus. Oh my God. Okay. Yeah, they are in another level. Right. Okay. Okay. So grammar. Okay. And I think this is something important to understand, because as you dive deep into all of this kind of concepts, especially when you are writing, is all of this code, set of instructions, expressions, tokens, blah 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 blah, you started to understand that we are reading is a language. We are more familiar with Spanish or English language, but also there are other languages as well that conveys to that. But this is important to understand is now this thing, punctuations and mechanism. All right. Okay. Okay. So the JavaScript generator is a syntactic form of describing a state machine. Syntax refers to the arrangement of words. Okay. Syntax refers to an arrangement of words that are grammatically correct. Exactly. So, syntax refers to the specific structure of arrangement of word in sentence, which state how meaning is conveyed in language. So syntax refers to the arrangement of word okay. Syntax refers to the arrangement of words, okay, for constructing grammatically correctness sentence. So syntax refers to the arrangement of word for constructing grammatically correctness sentence. For constructing grammatically correctness sentence. In grammar, okay, okay, grammatically correct sentence. For example, here. Hey, no, that's not how it works. No, in grammar, is the set of rules that in a grammar is a comprehensive system of rules. Exactly, and a grammar is the comprehensive set of rules. What the French toast? Comprehensive set of rules that govern language. That govern the structure of a language and include syntax, the way of how we arrange words to convey into a grammatically correct sentence, this set of rules that governs language that include is the syntax, the way how do we rearrange elements here, the syntax, the morphology, okay, prefix, suffix, and root words. Okay, the syntax, the morphology, prefix, suffix, okay, and root words. I get it. In root words, the phonology, the sound in the language and how they are organized, the phonology and semantics. And when Carl Simpson mentioned sorry. So when Kyle Simpson described here that the structure that generators is a syntactic form of a state machines, if you have this arrangement of words in this language for this grammar, all right, we don't like other language. We don't have, for example, phonology in JavaScript because this is a language that we convey to actually talk to machines, all right. But it is syntax as well as it has its syntax, morphology, all right, the rearrangement of elements in a word, all right, the structure and formations of words, right, and phonology, again here JavaScript, because we don't use JavaScript to talk to each other. Right now, yes, we do. And the semantic is that to convey to a meaning. So this is state machine, okay? And a state machines, for those who are not aware of, which is something that if you're using now React applications, right, especially state, and you need to handle all of this state and how they convey and how you can organize your state, all right? And now in React 18, how they develop these notions of building your user interface like in a UI state machines, so you can define all of these different set of possible state. You can define it as a flow or a series of flows from one state to another. From one state to another in a declarative list, and declaratively list all of these transactions. And in declarative list all of these transactions, so how all of this state change happen. But again, it is so this okay. So this is state machines, and this is more visual on user interface. Is that you have all of this states that represent is now a user element, all right? For example, a button. So a state machines, for those who are not aware of that, is just a series of flows of states. Okay, it's a series of flows. So it's a way to have a pattern. But it's a way to have a pattern of a series of flows from one state to another, to another, to another, to another, in a declarative list with in a declarative and declaratively, and declaratively, and declaratively, and declarative lists all of these transactions out. But it's a way to convey a pattern. It's a way to convey something that is recurring here. Okay. So by combining is now this idea with UI, which is most likely what designers and UI actually are doing, right? In terms of know what are the things, in terms of have a visualizations of all of these flows, or series of flows. So by recognizing this pattern, these recurring things that happen, okay. So state machines, for those who are not aware of, this is a this is a way of having a pattern of a series of flows of states, from one state to another, and declarative a list of all the transactions out, right? But it's important to have this mental visualization here. Why is this? Because with generators, it's exactly what we're doing here, but for our functions, execution. This is something powerful. Oh my God, because this, so we're trying to implement this pattern using callbacks and iterators, and it's something that requires a lot of work. If you're trying to implement this particular pattern, this is state machine. Okay. So for example, stately, for which is an actor-based state management. I'm assuming that they might be using is this. I'm assuming that they might be using is Xtype versus TypeScript, no framework with framework and that kind of thing. So this is now a way. This is now a syntactic form of a state machines. Oh my God. A syntactic form of state machine. It's like, hey, create this state machine. So visually create, edit, and collaborate on a state machines. Export to many formats, including Xstate version 5. Test pass and documentation auto generation. Deploy to stately sky. Here we go. Generate and modify machines with stately AI. State charts are a formulas for modeling stateful reactive system. This is useful for declarative, describing the behavior of your application from the individual components to the overall application logic. Again, this sounds very, very good, very lovely. Oh, look at this. Elsevier. When was this? It's Inside Computing, 1987. Jesus. Department of Applied Mathematics. The Weizmann Institute of Science. Red Hood, Israel. Shit. The literature of software and system engineering is almost on an anonymous in recognizing the existence of a major problem in the specification of the design of large and complex reactive system. And a reactive system, in contrast with a transformational system, is characterized by being, to a large extent, event-driven, continually having to react to external and internal stimuli. Examples including telephones, automobile communication network, computing operating system, missiles, avionics systems, and the man-machines interface for many kinds of ordinary software. The problem is rooted in the difficulty of describing reactive behavior in ways that are clear and realistic. Describing and at the same time formal and rigorous sufficiently so to be amenable to detailed computerization simulation. Exactly, state machine. However, it is also generally agreed that a complex system cannot be beneficial describing in this naive fashion because of the unmanageable, exponential growing multitude of states, all of which have to be rearranged in a flat, unstrained fashion, resulting in an unstructured, realistic, and chaotic state design frame. For example, here. So a state chart is state diagram plus deep plus orthogonality plus broadcast communication. State level clustering and refinements. Oh, graph. Oh, graph. Independency and concurrency. Oh, okay. We're getting to the weeds. Oh my God, Jesus, what a. Okay, main, admin status, team status, light. Oh my God, we're getting to the weeds. No. Okay, wait, what? No, that's interesting. Jesus, citizen quartz multi-alarm. So it has all of these different state machines. Lights, power, chip status, disable. And this is just as a way to visualize all the possible states here. Again, this is for big companies. Microsoft, for example, where they recognize that because they have these huge, massive applications where they need to visualize what the behavior of this. That's what they need a lot of these people actually having to take a look at this, see how this behaves. It's like, Again, the idea is quite powerful, yet because I don't have the resource and the money for that, I'm gonna leave that by this. But all right. So this is now so generators is a syntactic form of describing. Jesus. It's a syntactic form of describing a state machines. And for those who are not aware of, this is a way of describing, or this is a way to have a pattern. Okay, it is a way to have a pattern of series of flows. Oh my God! Here we go. It is a way of have a pattern of series of flows from one state to another, to another, to another, to another, and list descriptively all the transaction outs. That concept is something that you can now use in React applications as a way to describe what are the possible states that now these user elements can be. And that's when you have, for example, buttons or this small interactions. This small UI. So buttons, checkbox, selects, and toggles, you name it. Calendar. So all of these different state machines, like when you want to describe all of the possible state and list all the transaction out. Okay, but not only here for user elements, but also is for concurrency, but also is for handling is all of these different um, possible state that your application can be or your function can be. A generator is a syntactic form of a state machine. This will give us the magic key needed to solve this non-local, non-sequential. Because with this state machine, you can say, hey, once you get in here, I want you to now run this, okay? Or go to this, run this, and by the time that is done, return that. So we don't actually have to go there. It is a state machine that will go for us. But we need to also look at the plumbing here of this. Jesus. We need to take a look at the plumbing here. Okay. All right. Okay. Yeah. Very, very interesting. It was a problem I solved. This intellectual thing, this intellectual stimuli, It's intellectual stimuli, It's intellectual stimuli. And here we go. Okay. Yep. because now they're analyzing his token. Damn, son.
Als ik naar school loop, dan zie je de metro. Ja.
Ja, klopt. Signal inderdaad gaan. Oh, ik zie nu ook een lampje aangaan. Holy shit.
Op die manier informatie vergaart over mensen.
Ja.
Control back to line 8. The line 8 could then proceed immediately to line 9 and call .next again and resume it, so you can synchronously step through it. But of course there could be a break, there could be a gap, there could be a delay in time between lines 8 and 9. And in that period of time, the overall program continues to run without change, but what's different is that inside of this generator, it's in this paused state. It's blocking, it's waiting for somebody to come along and call the .next method again to resume.
All right.
This is going to feel strange and bizarre to those of you that haven't worked with generators before. So just like everything else, what I'm suggesting to you is not in 5 minutes you're going to be an expert on this pattern, but I'm trying to suggest to you, if you trust me at all, trust me that this is where you should spend a whole bunch of time thinking and practicing and reading, because it's going to change everything that we do with asynchronous programming. I'm 100% convinced it's one of the most revolutionary changes to our language. That's why we spend time thinking about it. Okay, so if we can pause a generator while it's running, it's also message passing.
So the TLDR of this generator, we described it in terms of what is the problem that it solves, one, and now we're going to describe what it is. Okay. And then we're going to describe this in terms of what it is. Functions, passing arguments, defining function here as generator. Okay, generator object. Okay, is returned by a generator function. Right. So generator function here creates a binding of a new generator function to a given name. So you create a binding. Okay, it's an association to an identifier with a value. So it's creating an association between the identifier with a value of a new generator to a given name. A generator function can be exit and later re-entering with its context. Variable bindings, safe across re-entries. It's not too descriptive, by the way. function expression can be used to define a generator function. Generator function does not have arrow function counterparts. Functions and are separate tokens, so they can be separated by white space or line terminators. Okay. So a function declaration creates a generation function, right? So we just provide an object method for the generator function. So in JavaScript, every generator function is actually a generator function. Okay. So it creates now this generator function. And this generator function object, okay, note that the generator function is not a global object. It can be obtained with the following code. So generator function is a subclass of a function. It's one of a kind of a function, right? So each time a generator function is called, it returns a new generator object, right? So which conforms the iterator protocol. The iterator and iterable protocol. So hey, this is now the behavior of how we're going to iterate through this. This is the iterative behavior, all right? And this is now the iterator protocol is the sequence of how we're going to produce these elements as we iterate through that. So when the iterator next method is called, the generator function body is executed. Okay, so when the iterator next method is called, the generator function is executed until the first yield expression, which specifies the value to be returned from the iterator or with the yield. Delegates to another generator function. The next method returns an object with a value property containing The next methods return an object with the value property containing the yield value and a done property with indicating what is the meaning of yield? Yield in Spanish? Yield, ¿cómo ceder? Yield. Yield in Spanish. Producir. Okay. Yield. Oh, that's what they producir. Okay. Yield. Produce or yield. This is a British term. Okay. Yield delegates to another generator function. The next method returns an object with a value property containing the yield value and a down property, which indicates whether the generator has yield its last value as a boolean. Calling the next method with argument will resume the generator function execution, replacing the yield expression when an execution was paused with the argument from next. Oh, generators, this is when they describe, okay, MDM docs actually, you need to read the MDM docs, bro. Generators in JavaScript, especially when combined with promise, are very powerful tool for asynchronous programming as they mitigate, if not entirely eliminate, the problems with callback, such as callback hell and inversion of control. And they put this link to Frontend Master. Jesus. And they put this link to the Frontend Master, bro. Holy moly. However, an even simple solution to this problem can be achieved with async function. A return statement is a generator when executed will make the generator finish. It has the done property of the object returned with by it to set to true. If a value is returned, it will be set as the value property of an object returned by the generator. Much like a return statement, an error thrown inside the generator will make the generator finish. Exactly. A return statement will execute or will terminate the generator, run to completion. unless called with the generator's body. When the generator is finished, subsequent next call will not execute in any other generator code. They will just return object on this form. Value undefined, done true. So function asterisk declaration behaves similar to the function declaration. They are hosted on the top of their scope, and they can be called anywhere in their scope, as they can be redeclared only in the certain context. So, all right, okay. So with all of those jargon, so a function or a generator is a function, okay, or the generator, exactly. So the a generator is a function that return is a generator object that conforms is the exactly a generator is a function that returns a generator, or it's a function that returns a generator object that conforms the iterable protocol, or in this case the behavior, the custom, you can say the iterative behavior, okay, the iterable protocol, the iterative behavior, that's right, the so iterable protocol can be described in terms of the iterable behavior. Okay, in generators, the iterable protocol can be described in terms of the iterable behavior in function flow control, right? God damn it. No, but in JavaScript, bro. By using function flow control, GL. Yeah, but since generators compliance or conforms the iterable protocol and iterator protocol, so it is safe to assume that iterable protocol refers to the iterative behavior. It refers to the function control flow iterative behavior, and iterator protocol, the values or the sequence of values generated by the GL keyword. That's not quite right. That's not quite correct. are a convenient way to implement both protocols at once. Use yield as a language features to create an implementation, and the Python runtimes automatically implement both protocols. So while generators do implement both protocols, the protocols themselves are abstract interface that can be implemented in many ways. The yield keyword and function flow controls are just one implementation strategy. Exactly. Not the definition of protocol itself. It's a one implementation strategy. So it is safe to assume that generators is a way to have function flow control execution. So generators is a way to have flow control execution. The iterative behavior and the iterator protocol. Okay, an iterator protocol. The sequence of values provide. But so generator is a way to have a function flow control execution. Generators are a way. So generators or generator is a way to have function control execution. No, generator is a way to have function flow control execution. So no one on the outside can preemptively interrupt the execution of this program. This is known as cooperate concurrency rather than preemptively concurrency. So line 7 here, instead of producing a function, it produces an iterator, and it is a pattern for stepping through a typical an iterator. So iterator is a pattern for stepping through typically. It's a pattern for stepping through typically a data set, right? This. An iterator is a pattern for stepping through typically a data set. Stepping through. But the purpose of this iterator in this case is not to step through data, but into the control of the generator from the outside. So generator is a way to have a function flow control execution. Jesus, French those guys. So, holy moly, bro.
So here, I'm not just calling yield, but I'm actually calling yield with a value. In the previous case, when I showed no value in the yield expression, it was assumed that I was yielding undefined. But here I'm yielding actual values like 1, 2, and 3. And you notice that when I call yield 1, I return control back to line 9 by way of returning a value. So .next returns us an object that has two properties on it. It has a value property with the value that was yielded, if any, and it has a done property that tells us true or false, is the generator complete. So that's why we get value 1 done false. And then we can call .next again right away or at some later time, and we're going to get value 2 done false. And then we're going to call it again, and yield 3, at that moment it kind of looks to you visually like the generator is done, but it's not really done. That's why we still get done false, because technically it's paused on that last expression. Even though visually we can look at the generator and say it's not going to do anything else, technically it's still paused. Technically you can still do something with it. So that's why the fourth .next down there on line 13 would resume the generator at the paused line 4. Immediately there's nothing else to do. It would finish, it would complete, and then we would get an object back that there was no value given to us, but there was a done true. Now what about that value undefined? Where do you suppose that comes from? Where it comes from is that in JavaScript, all functions that don't have a return statement imply a return undefined at the end. So there's an implied return undefined on line 4.5. Had we chosen to do a different return value, like for example return 4, we would have gotten value 4 done true on line 13. Does that make sense? So at any point when you do a return from a generator, you immediately complete the generator, and whatever you've returned is sent out as the value. But if you do a yield, the value is sent out and you get a done false. Yeah.
Can we iterate it, like do a for each as like a collection and get the value instead of moving one .next at a time?
Sorry, maybe ask the question.
You're doing it.next and you get the value, then you do an iterated .next, you get the next value.
Yep.
Instead, can we loop through like a for each loop, like a collection?
Can you automatically run through a whole iterator? Absolutely. That's actually got nothing, not specifically about generators. It's any iterator can be run through a loop.
Exactly.
You could do your own like for, I loop like that. You could be looking for the done true thing, and then you would know that you're like a while loop looking for done true. But there was a new looping style added to ES6 specifically for consuming iterators.
Exactly.
And it's the for of loop.
There's a for of loop.
So instead of for or for in, we now have a for of loop. And if you give it an iterator, even one from a generator, if you give it an iterator, it will run the iterator to completion. And it automatically looks for the done false and all that stuff. So if you want to consume an iterator, there is a looping syntax for it. But that's a very synchronous syntax, which may or may not be what you want with a generator. All right, so this is clearly illustrating that messages can be passed out. But it turns out that this is not only a one-way message passing, but actually the yield and the next pair together to create a two-way message passing system. So not only can we yield messages out, but when we call the next method, we can pass a message in, and that message goes into the generator. I'm going to create a little helper for myself, just to save space on the slides. Don't get too wrapped up in what this is, but it's wrapping around a generator. You see on line 2, I'm executing my generator to produce an iterator. And then I'm returning a function that every time that function gets called, it's going to call the iterators.next, pass in any...
It's going to call the iterator in there. Passing is the arguments, or passing is the...
arguments and return any value out.
Passing is the argument. Return the value.
So I'm just wrapping up the iterator.next in something that's a little cleaner and easier to illustrate with. But anytime you see the usage of this, you can just think, oh, it's just calling .next under the covers, okay?
Is that the coroutine? Oh, is that calling .next? Is that calling .next?
So this little helper, I'm going to pass my generator to it, and what I get back is going to be a thing I call run. So run is a function. Every time I call run, it's calling the iterators next. So whenever you see run, just think it.next. All right, so I haven't run anything in my generator on line 1, but I've simply set up this generator to be executed. And on line 7, I'm going to call the first run. That's the first it.next call. And it's going to transfer control up to line 2. Now on line 2, it's going to start to execute. It's going to say var x equals 1 plus, and uh-oh, I see a yield expression. I cannot complete this statement at this moment. So I'm literally going to pause the generator right in the middle of this statement and wait for somebody to resume. Okay? So that yield keyword is going to return control to line 7. Now that value that came back, the it.next return value that we would see here, would be an object that says value undefined, because we didn't yield anything, done false. Is everybody with me? Value undefined, done false. Had we yielded something, it would have been value whatever we yielded and still done false. But here's where I want to tweak your brain a little bit, because this is all about perspective that helps you understand how, or gives you a path for understanding this. What I want you to do is I want you to think about the perspective not from the outside world, because the outside world is how we typically would think about it. We'd think about driving this generator by our run calls. I want you to think about it from the inside perspective, from what's happening in the generator. At the moment that I am on line 2 and I encounter a yield keyword, essentially this yield keyword is asking a question. It is saying, I need some value here. It's like a placeholder that says, I need some value and I don't have it yet. I'm going to wait around until somebody gives me a value. Okay, because I obviously need a value to finish the statement. Does everybody agree with that? Okay, so I'm simply going to pause waiting for a value, and I will tell you, outside world, that I've asked a question. I am asking for you to give me a value. At some later point, like line 8, we're going to answer that question by sending a value back in. And that value 10 will come in and will replace or complete that yield expression with that value. So now the generator can resume and it can finish its work because it says, thank you for answering my question. The answer to my question was value 10. So now I can add 10 and 1 together and x is 11. From the inside perspective, that's the key perspective you want to have. Don't think so much about what's happening on the outside, because the outside stuff is actually going to end up being buried away in some library. It's the inside stuff that matters. It's what's happening on the inside of the generator. I'm asking a question. Now here I asked a very simple question. I just said yield. I said, give me some value. But what if my question was like making an AJAX call? And I said, I need a response from an AJAX call, and I don't know how long it's going to take, but I'll just wait around until you give me a response. So we could have yielded an AJAX call. Okay? So we've sent an answer back in by way of value 10. X is now 11. We go to line 3. We start executing y equals 1 plus, and another yield keyword. So we're asking another question, which means we're going to pause and wait for that answer, and we're going to return control back to line 8. Line 8 is going to have an object, value, undefined, done false, just like line 7 did. At some later point, we're going to answer that pending question by passing in the value 30 as we're doing on line 10. So that value 30 is going to come back and complete the yield expression that was waiting on line 3. Now 30 can be added to 1, and now y is 31, x was previously set to 11. And now, even though it's confusing with all these arrows, line 4 is going to yield out a value. You see there's a value that I compute, x plus y. It gets computed right away, which is the value 42. So that's me asking a question with the value 42. So I'm going to send out the value 42, and that's why I can say dot value, because I got an object that said value 42 done false. I'm going to run through the arrows at least one more time, because I know it can be kind of confusing. All right? Yes.
At this point, it said meeting. It's printed out meeting of line 42, or it said
after line 4 runs, we return the value out, and it would.
Okay. Well, so that'll be all for this video. Take care. Bye bye.